You know, a question has come in about coelution, and let me talk about this topic because ultimately this is the Achilles heel of chromatography. Chromatography is the world's most popular analytical tool. Every chemical analysis done in the world today is done by gas or liquid chromatography. So this is the tool that we rely upon, but there's one place where chromatography does not work, and that is what we call coelution. When two peaks come off at the exact same time, we can no longer identify peaks, we can no longer quantify things properly. So let's talk about coelution. To me, the biggest question is, how do you know you have coelution? You see a peak, it's symmetrical. How do you know it's a pure peak, or is there something underneath it? So that to me is step one. How do you know you have it? And it's not an easy answer. How do I know I have coelution? If two peaks are perfectly coeluted, you don't see any deformation. So the first thing we look for is some asymmetry. We would love to have a tall, skinny peak. If we have a peak that has a shoulder, if we have a split on the top, if we have what looks like two different peak shapes, again, I would call that a shoulder. I call that a shoulder. A shoulder is very different than a tail. A tail is a exponential decline, whereas a shoulder is a discontinuity. So when you see a shoulder, that you could have a problem with your column, maybe a dirty frit, but this is also an indication that you have two peaks coming off at the same time. So how do we tell? Well, we look for peak symmetry. If you have a diode array detector, this is where the diode array is worth its weight in gold, because you could do what's called peak purity. Peak purity, to sort of make it simple, it looks at a peak, and across that peak, the data system has probably collected 100 UV spectra. All 100 spectra should be the exact same, right? It should be a clean, if it's a pure peak, they should all be the same. If the 100 spectra are different from one another, then the computer says, hey, this must be coelution. So diode array detector using peak purity, a fantastic way to get at it. If you're doing mass spec, what you do is you take mass spectra along the peak and you compare them. So to me, that's the biggest deal. How do I know I have coelution? Because if you know you have it, then you must deal with it. So in a way, it's sort of, you're lucky when you see the shoulder, because then at least you know you have a problem. So then the question becomes, how do we get rid of coelution? Well, that's the fundamental chromatography question. That is the resolution equation. So when you have coelution, it means you have two peaks with the exact same, that are coming off the exact same time. That means in the resolution equation, we're missing one of the components. So to just give you the simple review of resolution, to resolve those two peaks, to resolve any two peaks in any GC or any HPLC, you need to have three things. You need to have capacity factor. And capacity factor really means you need to have your molecules spending some time in the stationary phase. So if you told me you have two peaks, they're coeluting, their capacity factor is 0.1, it's coming off with the void volume, I'd say I'm not surprised. We want this capacity factor to be roughly between 1 and 5. So if your capacity factor is really low and you have coelution, I'd say, yeah, of course you're going to have coelution. All you have to do is weaken your mobile phase. So if this is HPLC, we simply weaken our mobile phase. Guaranteed, we're going to get a higher capacity factor. So the next thing we need is selectivity. And selectivity is the hardest one because it's the chemistry, but here's the way I look at it. If you have good capacity factor, if you come to me and you say, hey, I've got a capacity factor of 5 and I'm still getting coelution, I'm going to start suspecting we have a selectivity problem, which means the chemistry that we're using in the column can't tell the difference between these two molecules because they have that same chemistry. So let me leave that alone for just a second and just tell you the third one is simple. It's efficiency. And efficiency is just a measure of the skinniness of the peak. So the first thing I would say is, if you have bad resolution, clearly one of these are bad. Let's figure out which one it is. If your capacity factor is bad, we're going to weaken the mobile phase. If your efficiency is bad, that means you need a newer column. You need to call up Jeff and Ed at MacMod and say, give me one of your new modular dispersed columns, get this efficiency number up there. Once you have a big number for efficiency, you got a good number for capacity factor, selectivity usually falls into place. We want this to be greater than 1.2. If this does not work, then if you have 1.00, if this is your problem, then come back and sign up for Axion Lite and join one of my free seminars on HPLC method development. But my easy answer is, right now, change your mobile phase. Whatever you're using, if you're using methanol, go to acetonitrile, acetonitrile, go to methanol. And the second step is check out the list of columns that MacMod has, the chemistries they have available to us today. In my day, we had C8s and C18s, but now they have a beautiful C12. They have a biphenyl a column, so two benzene rings hanging off of it. They have an AR column, an amide column that I really like for dealing with polar compounds. So this, when you have a bad selectivity, it means you have the wrong chemistry, the wrong column, or the wrong mobile phase. So it doesn't mean it's a bad column, it just means it's the wrong column for this application. That's how we can tell when it's time to choose a different stationary phase when we have no selectivity, when that is 1.0. So hopefully that helps. It's a big question, and it deserves a big answer, and that is coelution. Because remember, when coelution happens, all bets are off. We don't trust the results coming off the HPLC or GC until we could resolve our peaks, and that's how we resolve them. If you have more questions, you can come join us at Axion Labs here in Chicago. We run week-long courses where you spend 5 days taking apart the instruments, put them together. We have 12 LCs, 12 GCs. You come here and have fun with the instruments. So if you have questions, let us know. We're happy to answer them. Let your MacMod folks know if you have questions, and they will forward them on, and we'll produce some more fun videos. So we'll see you the next time.